All right. Let's tackle this, guys. Okay, so we've got a couple of errors that we need to kind of talk about. And I'm just going to introduce them right now as their formulas. So, and I'm just going to use number 19. So when you look at number 19, this is kind of the ideas behind it. One of the things that came up when you guys were looking at that AP Classroom piece, alternate series, there's conditions. It's got to have alternating signs. The terms have to decrease in the absolute value like this. The absolute value of this term, it gets smaller and smaller and smaller as it goes. And then in terms, the terms approach zero as a limit. So if we did the n approaching infinity, they'd approach zero as a limit. So when it comes to sine of x, we know that it's an alternating series based on the Taylor setup, or the Taylor polynomials. And so in 19, they ask you to do two things. They ask you to come up with an alternating series error, and then they ask you to come up with a Lagrange error here. So two formulas you got to use. So we'll just talk about the one you guys already know, that it's the error of f of the function n plus 1, the term n plus 1. So when we look at sine, they give us this in black. This is what's given right here. And they tell us that this estimates the sine of x at 0.5. So if what clicked for me was I needed to know these first few terms in my brain so I could kind of pull it together. And then for the sine, the Taylor or the Maclaurin is x minus x cubed over 3 factorial plus x to the 5th over 5 factorial. And the reason I needed to know it is I was looking at this going, where'd the 6 come from? Well, it's right here. It's 2 times 3, because this is 3 times 2 times 1. Well, 3 times 2 is 6, times 1 is 6. So that's where this comes from. So when we're looking at this, we're looking at the alternating series for sine, which all these conditions are met. So we can actually have the error being less than this. So we would go to the next available term. Now what we got to remember is that next available term is 5, because 3 and 4, every other one, the even ones are skipped when it comes to sine. If we had cosine here, this would be the odd ones are skipped. So we got to know that the next available term is this one here. And so we want it evaluated at this term with that a. So this error is going to be wrong spot, 0.5 to the 5th power over 5 factorial. You can use that calculator and you get some really, really, really small number. I can't remember exactly what it is. In fact, I have it written down right here. So if we look at that, that's going to become 2.6 times 10 to the negative 4th. 2.6 times 10 to the negative 4th. So our error has to be less than that, okay? So our error has to be less than this piece here when it comes to the alternating series. So the alternating series, I just picked the next available term. Now as we move and we don't get an alternating series and we're just dealing with a straight Taylor series, we're going to be able to use Lagrange error bound, and they also call it the Taylor's theorem, I believe. So the remainder is less than the Taylor series n plus 1 evaluated at the center with the difference to the n plus 1 over n plus 1 factorial. So this is the main piece of information. Now, remember that this is whatever Taylor series you have. So that whatever Taylor series term you're dealing with is what you're going to evaluate right here. And that's kind of what threw me off completely. Is I need to go, number one, we're still working with the third term here. So the third term is basically the same as the fourth term, so we need to move to the fifth term. So we've got to use the fifth term here. Now the fifth term has to do with the derivative here, the fifth derivative, and the fifth derivative of that one is cosine, okay? And the center, since we're not moving left or right, the center is at 0, so the cosine of 0 is 1. So when we're dealing with this, we are going to get this, and it's going to be the absolute value of the cosine of the c, which is going to be the center, and then we're going to multiply that by x minus a. X minus a is 0.5, because that's how far off we are. That's where we want to evaluate it. I believe in the problem it says this, sine of 0.5, and we're estimating that piece. So how far away is it? Well, it's a, and so our center is 0, so this is going to be 0.5. So this is still going to be 0.5 to the n plus 1, which is 4 plus 1, right? Because the fourth term is now, it's the same as this one, so we got to go one more. And then we got n, we got 4 plus 1 factorial. So if we look at cosine of c at 0, cosine of c is going to be 1. So therefore, this is going to be 1. So that doesn't really matter, and we end up with the same answer. So we're going to be with 2.6 times 10 to the negative fourth. 2.6 times 10 to the negative fourth. Okay? So we have two types here. We have the Lagrange error bound, and we have the alternating series. And the alternating series has conditions that it's alternating signs, the terms decrease in absolute value, and the terms approach 0 as a limit. Number 19 requires you to come up with both of them. The reason they're the same, is because we're dealing with this derivative that's going to put it at 1. So just kind of depends. They both can work, but this one can only work for an alternating series error bound. Now the Lagrange, you can set it up using all the Taylor series. So just kind of watch out. I think for you guys, knowing those main ones of the Maclaurin and knowing and working through them pretty quick, I think that's going to be super helpful. So remember that these pop up because they're finishing these factorials. So this one comes from 3 times 2 times 1. Okay? So, so this is how we're going to tackle 19, 20, 21, 22, I believe. Let me look at that. Yeah, those are the ones that we tackle in tonight's assignment. So you're going to be dealing with an alternate series bound, and then we're going to be the Lagrange error bound. But remember, this one here comes from our derivative. So hopefully that's helpful. It's starting to help me understand what's going on, and we'll see you guys soon.